hello everyone. I'm happy to welcome you to today's virtual talk. You can look forward to exciting presentations about the topic Think Modular, Act Digital, Innovative Solutions for the Process Industry. We are thrilled to offer you this platform, providing a unique opportunity to engage directly with experts and industry professionals. Your input is invaluable, so we encourage you to share your suggestions for topics that matters most to you. And PowTech Technofarm is all about community, and we want to ensure your voice is heard. With just 4 months to go until our next event in Nuremberg from September 23 to 25, 2025, be sure to mark your calendars. We get into this topic, and I would like to thank our speakers, Dirk Steinhäuser from Glatt Ingenieurtechnik GmbH, Heiko Hegemann from BOECKER OHG, and Tobias Werner from Jakob Group, without whom this would not have been possible. And now I don't want to talk too long, and I'm looking forward to the first talk by Dirk Steinhäuser from Glatt Ingenieurtechnik GmbH and his talk about modularization of pharma, API, and FDF production plants. Enjoy the talk.
Hello, good afternoon from my side. I will just share my screen, just a second. And we go into presentation mode. Yes, my name is Dirk Steinhäuser. I'm Vice Head of the Dresden Engineering Hub of Glatt Engineering. I'm a process engineer by background, by profession, but I also have a scientific degree in biotechnology from a university in the UK. First, I would like to give a short overview on Glatt Group and what we are doing. We are a group of about 3,000 people working in different companies in different countries and regions, and about 14 companies, and we are from the engineering division, and our other divisions and branches are especially the equipment, but also pharmaceutical services for development and food feed fine chemicals. From the engineering division here in Germany, we have a number of offices and hubs. The main hub is in Weimar, the headquarters, and I'm situated in the plant here in Dresden, in the office building where we have an engineering hub in the 5th floor. We are working on a number of topics in pharma, biotech, biopharma, as well as food, feed, fine chemicals, and also the chemical industry and certain fine chemicals. Within the pharma and bio, we are dealing, of course, with active substance, APIs, active pharmaceutical ingredients, both biotech and chemically, but also based on specialties or on special raw materials like blood plasma. And for the finished dosage forms, the FDS or the drug products, we are especially focused on solid dosage forms, but also liquid dosage forms, steriles, and certain specialties, medicinal products, applications, plasters, sprays, you name it. We have worked for a number of companies. Here is just an overview on the different customers we work for. This is just a selection of some big companies, some medium-sized companies, some small companies and startups, and it's just a selection of some of them, is not all of them. The approach that I'm going to show is derived and developed together with projects where we have developed and gained our experiences. Here are some examples. A company where we have done a lot of work is in Dessau, IDT Biologica. We have done projects for ATMPs, these are advanced therapy medicinal products, vaccine projects here in Dresden for GSK, but API projects, for example, here in our valley of the River Elbe in Radebeul for Areli Pharma, which was the former Hexal, now part of Yongsung Group from Korea. And this is a plant in Germany. It's also an API plant with modular trains. Sometimes the API plants have high requirements towards operator protection or product protection, so we apply containment. And there are certain OEB, OEL definitions applied in the plants. And these kind of plants sometimes even are structured on the plant level into modular approach. So we have like process flow diagrams and P&IDs for the different units of a complex plant step or plant unit. for example, like a feeding station to a reactor, or condensers, or evaporators, or collection tanks. So all these kind of process parts can be modularized. There are other examples we applied in the blood plasma industry in Turkey or in Germany. Also do this abroad. Here is a part of a large biotech campus in Thailand, which was designed in modular way. And it was a project during the pandemics. It was difficult, but it was implemented, and it was built during the pandemics. Of course, our travel was restricted, but the construction company was local, and it moved forward quickly. So already in 22, the building was constructed, and afterwards, started to fill in with equipment. Such a biotech campus, like here in Thailand, is also being built at the moment in Germany, in Straubing. This is an image of the conceptual design phase for biocampus multipilot in Straubing, the ID phase, and then it was designed in concept and basic design. First equipment modeled in 3D, the piping, and then, of course, the building, the architecture, also with solar panels and some other sustainable energy modules. This is still the design phase with an appearance of like some natural materials, and has been built accordingly. There's an image of November last year, already half a year ago, and now the building is more or less completed. And in such a project, it's not only the process, there are other disciplines like utilities, automation, electrical, and all these require their space and have to be coordinated. And the first tool to coordinate these trades or disciplines is the layout, where everything comes together, because all of these disciplines have their space requirements. And these projects go along in phases. Many of you know these project phases, like concept, basic, detail design, and then starting the procurement, and as soon as the building is constructed then and equipment delivered, going further into construction management direction, and then the installation phase coming further to commissioning, and for pharma projects also qualification. However, the first starting point is always the design basis, the process or the process requirements, the defined process. And even if the process is defined, are further design principles to be discussed, especially in the GMP pharma environment. For example, the discussion, what is in a clean room, what is in a technical space, which classification of clean room is applied. So we discussed this very early, derive it from the GMP requirements, and then assign the classification to the function, and also discuss the function, collect all these kind of necessary steps, equipments, support functions into a functional program. This is also the basis for the next step, which is later the room list. And we are structuring these functions with a color assigned for the GMP classification, for the clean room classification, and then structuring the personal and material flow accordingly. If there is a jump in the class, there will be airlocks or material locks or personal locks. These are this with the slash sign here in the middle, or with the where we have both colors. And this is a method which comes from ISB organization. We didn't invent it, but we apply it a lot. And it helps also to structure a plan without a discussion of specific room sizes, like then you end up in discussions, why is his room larger than mine if it's an office or lab? And also the allocation of certain functions can be structured primarily based on technological aspects and GMP aspects. With these functions, we also assign the necessary space for operation, maintenance, sampling, taking a sample, but also feeding of product or raw material, the handling for that, like for example, lifting devices, hoists, etc., heat exchangers, pumps. So all these units, all these systems require their space. And so we have, for a complex function, like this case, we have buffer prep and hold area, not only the two tanks, but also the periphery considered in the overall layout, typical, as we call it. So we have a library of all the functions we've come across or that usually apply in such a project, and have them also in different volume or capacity ranges. With these blocks or ideal layouts, we can apply these for the different configurations of the layout. The first arrangement in horizontal and vertical way. Also, there's technical spaces. What are the spaces and the dimensions? This is still very conceptual. This is very preliminary, but it gives the first indication and it gives a structure into the layout development. With these blocks and behind that are the details. So this is a bit simplified, and behind there are the details. So it's really proven within the detailed drawing that these measurements are kind of realistic. We can apply these in layouts in a 2D plan like in Visio, but also have a simplified 3D model, a modular space module. So to have a structure, for example, for API plant where we have technical spaces, where we have a kind of a middle corridor for some functional units. This might be open space, but you have certain reactors left and right-hand side, and this can be accessed, and then like cooling or heating media, they can be connected to the technical shaft or area. And with these kind of cubes, it can be kind of played around or structured in the way like it is symbolized here, even if there are questions like free modules or modules for extension. It gives a good tool set to discuss and develop arrangement levels, like how many levels, floor levels, how many like grid levels in the horizontal perspective. And then we can also compare variants where we have different configurations, staggered approach, or like one main reactor level. And if you have to consider certain requirements or constraints from the construction or from the land plot, then we can also model these or play around with the different variants. Then this goes further into a layout section, first like a block layout section. Here we see already the different levels from API plant. Above there might be some ventilation technology, also even purification or recovery. And then some process feeding, reactor level already in a different clean room classification, going down further into separation of crystals, and then drying and, for example, filling or feeding of containers for the further bulk processing or storage. In oral solid dosage forms, here we see a kind of a granulator type in a vertical arrangement, and then the following steps like tabletting, sometimes coating of tablets, packaging, and then secondary packaging, which is the cartoning. And the different scenarios can be considered or kind of modeled, or what are advantages and disadvantages can be discussed using this approach. This will be detailed out further from the principal layout into a functional layout. So we see this kind of more detailed drawings. This already can be at the end of the concept design. And just to indicate the depth of the equipment, like we have certain filter centrifuges or double cone dryers here in vertical, but also in the horizontal perspective. For OSDs, we also have developed train concepts that is going beyond one module, considering the neighboring module like dispensing or tableting, and even further to packaging. This is an example of a one product dedicated line. So straight one line for one product. However, there are other modules or other train concepts combining two trains into a hybrid train, so we can have more than one product. At the same time, we can use the different stations in kind of a workshop principle, going to the station. And for a mono plant, of course, this is for one product the preferred way, or if you have in campaign operation mode changing after a few days or weeks, then do proper cleaning and go there with the next product. You can run more products at the same time. And there are combinations of up to 5 train concepts we have developed and are using. These trains modules are all combined together in block layouts. Here, without equipment shown, but behind there are the equipment, or is the equipment information from the modules in more depth. So there is a safe space estimate underlying this design concept. Nowadays, luckily, in the past 5 or 6 years, the equipment suppliers also provide us with 3D models from their equipment. So we're getting from nice companies like Pol or Millipore or Sartorius such 3D models. And of course, we have a high planning certainty for the design of the layout when we receive such modules, and we are quite realistic in what is being in the final selection by the customer for the project. And here are some examples for single-use technology in a fermentation plant. In the model and in reality, and in this case, in a project, in a case study from IDT Biologica in Dessau, where we have special equipments like cell stack manipulators applied in this project. Utilities are supplied from above to the mobile units, quite flexible. Such is the building. It's a building concept developed together with an architect partner, PPM Group from Leipzig. We have flexibility within these main production compartments, 1, 2, 3, 4. Each one has its own airlocks or personal material locks, so it can be different products in the modules. Usually they are applied 1 or 2 of the modules for upstream and the other for downstream, and different classification is possible. Of course, final step is mostly the higher classification. Depending very much on the organism or on the process, it doesn't necessarily mean that we have to run them in class B, but it is designed to be able to have class B. There is the darker blue color here. There's a second kind of level for flexibility, that even if we can change here or apply different products to the production modules, the whole floor can be changed. In the clean room part, the clean rooms can easily be changed because the building structure is not affected, it's independent, it's a wide span structural unit. Air handling units are on this technical level, can be repositioned, moved easily, and gives another kind of level of flexibility to the plant. IDT is a contract manufacturer, so they face quite often a change of customers for whom they are contract developing or contract manufacturing. So this customer is provided with such an flexibility for their plant. And oftentimes is of major importance. This is from this IDD project with a fast track approach. That means in this case a lot of prefabrication of columns and slabs. So these are delivered, prefabricated, and within hours erected into a vertical position. And within 2 days, the whole building more or less was ready. And then here in the rear part already the facade is installed or attached. And then the front part is still the raw construction. So that is very fast building. And here is including the levels which are partly steel construction. And then already starting the work for the clean room ceilings and the clean room floors. HVAC level in this flexible structure that I've shown before. And then after that's prepared, then soon the equipment can be moved in. Yeah, and we have also very nice equipment like this roller racks here for the cultivation of virus cells. Single use, not only for chromatography fluids used like buffers or certain eluate containers, but also chromatography columns in single-use manner. One has to be a little bit careful when handling these. Sometimes there are probes and certain small pieces that are kind of measurement devices that are not single-use. So be careful when putting everything to the autoclave. Afterwards, they might be dead. So a very good training is essential to use these tools here. This is a view from the plant, and this is the new building 205, which was implemented into the site, which has 3 companies on it. And It was very quickly designed and built. So we see here after about 4 months, the construction had started, and after 1 month, the building was, the columns was there, and building closed within a few weeks, or 5 months after construction start. The main structure was there, and the building was closed, and then the clean room installation started immediately. So overall, the building construction time was like 12 months, and the overall time until end of the qualification, end of OQ, was 18 months, 1.5 years. For this kind of approaches, it's crucial to allow an overlap of phases or a staggered approach, and further also to use the time to go at little risk to do already design work or prepare tender documents during the detail engineering, or while the authorities are checking, to use that time for continuing with the project, not just await the decision from the permit, just to continue. Going further in the coordination in 3D from the concept with tools that we have in the basic design, usually Revit for HVAC in the main piping, and then going from basic design from routing corridors, space reserves into the detailed engineering, each pipe support, insulation, and further details, instruments, valves, everything. And then the overall plant is kind of designed. This is from a large biotech plant. Phase 1, this is a large fermenter. Another one was installed here, and then there's a older receiving tank, or kind of a product receiving tank after harvest. It was installed here. In the model, in the 3D model shown with the steel supports, just the difference, what was added in the model, and then the HVAC. So it is quite a task for coordination, and nowadays that's only done in a 3D model. Otherwise, to do that on the side would be time consuming and risk a lot of kind of errors involved. Yeah, Autodesk, the product group of Autodesk, AutoCAD and the Revit is the main tool platform we are using, but we have used also other tools. But in the last years, Revit has become more and more the tool of choice, also from customers or partners in building design and building construction. And the MEP, in German TGA, for process, we to some extent use AutoCAD Plant 3D because of certain features we use for sloping and isometric drawings we generate from the model, material takeoff, material lists, etc., which go directly to prefabrication spool pieces, and then these are labeled, and the operator or installation worker can take it on the shoulder, bring it to the right position. So it's a bit like Lego, putting it into the place, and then the plant is ready. This is from the biotech plant in Germany, which has about 100,000 liters capacities for the fermenter and the whole tank. And here we have a larger plant in India. That's a coli plant on the left side, India. That's a yeast plant, yeast-based fermentation with 350,000 liters. In this case, also the fermenters were built by Glatt, our colleagues in India, workshop in Pune. Here are some other projects with clean room requirements, plasma fractionation plant in Marburg for CSL, and a view into a process room where we have a strict separation of the clean room from the technical space. So the majority of the tank is in the technical space, and only the area that has to be accessed or where we take samples, these are in the clean room. Such looks completed biotech plant is round clean room ceilings, transparency. That's of a project for Roche in Basel. There we have a view from the road in Basel to the plant. This is the downstream side, and left is the upstream side. This facility was also awarded with the ISP Award for Facility of the Year. And behind that approach is the interdisciplinary phase model, where we have the different disciplines. All the workflow is defined, the process, the sequence of the events, so that nobody is forgotten. The space requirements of every discipline are considered, respected, and integrated. And for the modular approach, we have here the levels. So the level 1, the base level, is kind of the single individual equipment. Combining functions brings us to level 2. So this is a complex functional unit. That we have a granulation function, not only with the granulator, but all its periphery. And we have level 3, where we have such functional units combined to a larger functional area, a complete tabletting area or complete OSD area. And these functions can be combined into different building configurations, often together with an architect for the specific site, land plot, or if it's an existing plant, to the constraints and conditions there. For the modular approach, there is a method from Hegemann, VDI, GVC German organization. There's a white paper. We have been actively using that and contributing here. So there is a method, and often it's this combination of being flexible, of being cost competitive and fast, and a number of aspects are playing a role of like time to market, be fast, be flexible, plug and play, exchange, having new products. So all this together shall be considered. And with the modular approach, it's much easier because you can change a module or update a process rather easily. Just a few conclusions coming from the requirement. There are a lot of product changes after pandemics. There was the trend of the anti-obesity drugs, or still is. There is advanced therapy, personalized medicine, new peptides, oligonucleotides. All these products want to be installed, and sometimes our customers, contract manufacturers, or pharmaceutical companies change often, have new technologies, new products, go to different regions, geographies, sometimes leave a region for cost reasons or market strategy reasons. And we have to follow that and act flexibly and quickly, and also order equipment quickly. But nowadays, it's not just equipment which has long delivery time. Sometimes there are so-called time-critical orders, even transformers or certain valves with special metals or alloys. And all this needs to be considered, as well as the cost aspect. We try to involve, if it's necessary or seems feasible or recommendable, to use also our engineering partner, or Glatt India engineering in Delhi, to combine with, and a lot of also in the 3D tools, but also now the 3D becomes more and more BIM, the building information modeling. We are using AI in certain projects. We apply robots in production, but also in manufacturing of equipment and skills. So this is the situation. And the last slide is an outlook. There will be the trend of personalized medicine, small batch sizes, small volumes, coming even to 1 person, 1 batch. That's batch number 1, or batch size 1. These require more space, but small equipment. There are new developments like in vivo medicine or applications, which is incorporated or inserted into the human body. There are some examples here from Bayer or from an Irish company. For the biologization of the products is coming. Less and less chemical APIs, although they will remain. There are always a lot of new biological products, and all is now data covered. A lot of data are collected and generated. So all these famous words, big data, AI, are our reality, with the pharmaceutical dosage forms, with the registration, with the project, with the digital twin of the whole plant. So that's our everyday business, and all these needs to save CO2 and shall be energy efficient and sustainable. A lot of customers specifically ask for that, and we face this challenge and have solutions for it, and apply these into our projects, from energy to raw materials to production cycles. And this is a short overview on this topic from our perspective, and I'm happy to answer any questions to the subject that might have arisen.
Thank you very much, Mr. Steinhäuser, for your interesting talk. As he said, yes, you have now time to ask your questions over the F&A button. You see it at the bottom of your screen near the chat button. There is an F&A button or Q&A button. Please click on it and type in your questions. I will forward it to Mr. Steinhäuser. So we give you a moment that you can type in and ask. So maybe we can start with the first question. Is there any additional effort when planning modular, or is it more expensive, for example?
Yes, there is some initial, I would say, initial effort to kind of prepare it in a way that it can be used again for another project. But often when the project is finished, there is the time or the chance to digest the project and to what can be used or what are the lessons learned. And then we use also some of the design that can be neutralized or prepared for repeated use. And this repeated use, of course, saves time and costs for the next projects. And also because we absorb these lessons learned and general learnings, it gives us the chance to avoid certain design solutions that have been, proven good or bad, to improve it the next time, so that the risk of doing a mistake again is kind of eliminated, and we are faster and are closer to a situation that I would call a first time right, or that's in general called a first time right.
Thank you very much for answering this. Second question. So do the models for projects in Europe need to be adapted if the module shall be used for international projects, for example, in North America or in Asia?
Of course, there are different standards in the regions. In North America, there's a lot of ASMA, but this is also applied in the Middle East. So we, in the beginning, of course, consider where the project is going. But in the conceptual phase, it doesn't play that role because these general regulation and standards apply more to measurements on the plant and bolt measurement level. So the modules in general can be used in the concept design, even in basic. And then once you go to details, you have to go take the pipe classes for the specific region or the specific standard applied. And the only thing in the concept design, from my experience, is that there are countries where you have certain requirements for energy redundancies or certain rules of utilities. Then we have to look a bit more in detail. But yeah, from our experience, for the process, they can be widely used. In utilities, it's more regional specific.
Perfect. Thank you very much. So if you have any questions left, or you have questions after the talk and you want to ask them, please feel free to write also at PowerTech team or to me, so that I can forward it to Mr. Steinhäuser and also connect you with the contact data afterwards. So then I would say thank you very much, Mr. Steinhäuser, for your interesting talk. And now we will continue with Heiko Hegemann from Harvard und BOECKER OHG and his talk about perfect flow from single machine solutions to fully integrated systems. You can look for an exciting talk. I'm excited and enjoy.
So, hello everybody. Hope you can see my screen. Thanks at first to the PowerTech Pharma, Techno Pharma team for the invitation, and I'm glad to be here. My topic today is the perfect flow from a single machine solution to a full integrated system. And just a second, now it's working. As an agenda, the highlights of the talk, I will get more into detail for the project cycle we are using to listen to our customers, how we do the configuration of plants and systems, how we interpret and execute the horizontal and vertical integration of the data flow, and last but not least, the track and trace solution of products. But before, some words to our company, to Hegemann BOECKER. We are founded in 1878 in Oelde, Germany. We are a family-owned company. We have total globally approx 3,300 employees with a total turnover of 622 million in 2024. We are with the main subsidiaries located in Germany, but we have also the main production plants for our machinery in China, India, Brazil, and USA. And along with that, we have in total 50 subsidiaries with totally approx 115 representatives all over the world. We as solution providers, as machine builders, are segmented or are structured in our core businesses. There we have the cement and building materials. We have the chemical and food industry. And for these businesses, for these customers, we have our technologies. See them here on the right side, our technologies providers. And the aim is to provide solutions coming from the single machine up to a fully integrated plant with the building and the whole philosophy around it. So you as our customer has an idea, has a greenfield project or something like that, and we would have, with our matrix here shown, the right answer to fulfill your points. So how we do that? How we listen to the customers, and it's our aim to truly understand them in order to be able to advise and to supply them in the best way. Therefore, we developed the project cycle. That project cycle is based on 8 different segments, and these 8 different segments are used to cover all of the customer projects. Sorry, not projects, customer topics and answers. Today I've picked 3 of them to explain them more in detail and to show you this procedure. First of all, we have the project segment equipment. We will deploy the right machinery solution to your needs. And that would mean in detail, as an example, our new Integra machine. The Integra machine is a kind of machine for filling and closing valve bags. The machine itself is known into the market since decades. But as further development, we listen carefully to our existing customers to design with them together an outstanding new version. So the main features of such a machine are the approach, the main topic to do an energy saving. It's a topic in these days, it's everywhere here. We need to save our energies, but the question is always how to do that, how to really save the power, the energy. And we have used at first in the machine the recovery of the braking energy. So these motors in such a machine, they are sequenced against each other. And if the first movement, the first motor has stopped, we used these braking energy to energize the second or the next motor. Along with that, we have done a complete hygiene concept to be able to have a cleaning, optimized design of such a machine, to have an improved accessibility. To see this is a modular plug-and-play system. So we create those machines all over the world and ship them to the customer. And plug-and-play in this case means it's taken out of the container, of the shipping container. It's assembled by the main group. It's the machine frame. It's connected to its product hopper above the machine. And as precondition to be able to ship such a machine, need to be quite compact. And this compact execution is mostly against an improved accessibility for maintenance people or for cleaners to clean such a machine. If we are packing food products or chemical products also, it's quite important to have always a certain environment as a clean machine. And to access the small holes, the small corners, it's quite important. Along with that, to have also an easier maintenance possibility, we have moved all of the cables and all of the pipe work onto the top of the machine to have less technical items inside of the filling area and to have them all covered up on the rooftop. Digitalization is a quite important point. With that machine, we have a new approach for AI solutions. It's the valve check. We will hear later also some about that. And we have a centralized HMI. The aim of us as machine builders is to combine the single steps often planned, like the bagging machine, with a palletizer, with metal detectors, or with check weighers out of the belt conveyor. So we need to move the filled bag from A to B. In between, we have belt conveyors. And the aim is for the operators to have a centralized station to access the overall plant. Also a modular item, the new Amicus robot. Modularity in that way that we have multiple tools for the same robot. We have different tasks for the same robot. So we are coming up from the empty bag up to the filled palletized pallet of bags. And the same robot could either handle the empty bags to load them into such a bagging machine or to receive the filled bags. An example, you know, from the Home Depot or something, the 25 kg cement bags, for example, to palletize them on a wooden pallet. Therefore, we have different tools. It's the modularity to choose them against or according to your specification and your needs. Same way here, we have the digitalization in the way that we use the AI solutions as a bag check. These empty bags are mostly pre-printed. They are mostly given with a product name, and the solutions could help us to avoid that an operator loads the wrong bag to the different material. Same here, we have the centralized HMI. You could choose where you would like to control your line or your plant and have there the accessibility to all of the different segments. Second project segment is the consumable segment. And for the, we have there combining the main target filling bags, we try to ensure to make overall processes perfect. And the aim is here, we have the empty bags, and those empty bags are somehow a consumable, which are or which need a certain treatment, and to avoid that we have a misplacement. If we put such a bag on the filling spout, it sometimes could happen that the valve is not completely opened, that it's not possible mechanically to move such a bag onto the filling spout. And our solution, the valve check, brings us to the point that we check with the camera if the valve is correctly opened, and if not, to help the machine to, by themselves, identify this and to pick directly the next bag. This, as a benefit, optimize the filling capacity. No operator intervention is needed. We have a reduction of the product losses, because if the bag is sometimes slightly placed, the filling could be started and we have a kind of mess inside of the machine. But with the solution, we completely avoid such a thing. And this ends up in a savement of time for cleaning effort, and also save of time for the operator. Second thing, what we hear for the Amicus robot is the quadro bag check. See here in the picture such a bag, and the AI camera will recognize the imprint of the bag and will compare with the given example print and will inform the operator if this is not the correct bag for the product you would like to produce. This even also saves time, or minimizes the risk for any claims from the end customers. And we have a reliability because we are not using the wrong bag instead of the correct one in the first approach. Third segment, the plants and systems. It's the topic to combine the single machines, the single solutions into one complete solution for your requirement. Now we have single modules, and these single modules could be combined to have the final product. And this project segments is to use to get a holistic solution for your business. How we do that? We have different quadro products. These quadro is our digitalization branch, and it's the family of all these digital versions to optimize your plant. We will get later back to that. Mostly the big question is how you have a standardized, but even still modular approach to combine all of these steps. How is maybe the paperwork done with the customers together to select from the prepared solutions and to get them into a kind of order, in a kind of package which is needed by the customer. And for this, we use our CTO system. CTO means configure to order, and that configuration possibility is based on three different ways. First of all, we have the ATO approach. It means assemble to order. We have a complete set of prepared standards in the machines, in the functionality, but also in the plants and in the buildings. And you could pick from this with us together and select your final solution. If you see, based on this standardized catalog, that you are missing some items, or it is not anymore standardized, but you have that solution in mind, you have seen it before, then we have also the possibility to stick mainly on the ATO version, but to combine that ATO version with our MTO, the modified to order version, and to create something which is quite close to the standard, but not 100% the standard. So somebody need to think about it, do the engineering for it, but it's limited. In the end, if you're saying, oh, okay, you have nice standards, but I have a totally new idea. Even that is possible with the approach, saying we have the engineer to order version to think completely from the green field. You have an idea, we have the engineering, and together we develop your solution for your business. How to integrate that? It's always the topic, the aim, talking about Industrial 4.0, talking about digitalization or automation, how to really execute this, and how to make all the informations, all the data available on the right point. For this, I would show you what we have here before. On the right-hand side, we see our Integra bagging machine. This one is producing, for example, 25 kilogram paper bags. They are moved out onto a checkweigher, a belt checkweigher. We have here a metal detector to detect if there is any kind of metal inside of the bag, printing engine to print on the bags, and our robot cell, the Amicus, to get the bags palletized on the pallet. And the integration, first of all, for us is to use the HMB machine network to get the necessary information to fulfill the first phase, to have a productive plant together. And therefore, we have our main switch cabinet to do the distribution and to do more or less the central station to combine all of these information. Now we would like to add some of our Quadro product family products. Then we do a composition of the local network along with the control network. That control network allows us to have an access to the centralized station where the informations are gathered, to collect them and to make them usable in our Quadro products. By doing this, to have an access to the centralized information, we could also use mobile devices or any kind of input devices to allow the operators to have always the insight or to have a look on the dashboards to see what's happening in this plant. But not limited to the operators, it's also available for your customer EAP system to do the backup functionality, to do statistics or reports for the sales and for the production management. As an example, I would like to show you the Quadro Connect. That Quadro Connect is a centralized platform to gather all the informations from the centralized switch cabinet which we have seen before and to make them available for everybody. Mainly the focus on KPIs and to see the data and the figures of a plant. Secondly, a product called Quadro Visualization, and that's the aim to have a different point of view, a different angle on the data. The management would like to see different things from their production plants than the maintenance people. And that tool is more for the maintenance on the operator people. They have here the possibility to have the whole plant on one screen, to do the operation, to do the control purpose, but also to change the local parameters instead of moving to that machine and do it locally at each equipment. Talking about how to track and trace products, even or mostly or mainly in the chemical and the food industry, it's very important to have a complete reporting possibility to see when the products are produced, what is the parameter, how they are produced, what are the production parameters, like if it's metal containing, what was the check weight, and was it be printed? And all of this could be combined in a different product. It's the Quadro production. And this Quadro production brings us to the benefits to integrate all of this in one single solution. Along with that, we have also the option to do an automatic presetting, means we have a full flow of informations coming from your ERP system, like an order that could be uploaded into that station, and the station will do the necessary tasks to distribute that to your complete production line and to do the production information, what need to be produced, what is the bag, for example, it has to be used for the bag check, and how many bags you would like to produce. In the same way, it gathers the information from our central stations to do the reporting and to store it over years to have it always available when it's needed. So coming to the end, for HMB, the mission is to increase the efficiency and the innovations through the digitalization, and to allow a responsible way of handling resources with our AI approach. Your benefit is to gain a competitive advantage with our digital solutions. Yeah, the digital world is waiting. BOECKER will guide you every step of the way. Thanks a lot.
Thank you very much for this interesting talk and insights. Now, I think if you have questions, please feel free to answer it to Heiko Hegemann over the F&A button or Q&A button at the bottom of your screen. Please type in and I will forward it to him. So I will give you some minutes that you can type in your questions. And also, as you see on the screen, you can also write Heiko Hegemann or the Powtech Techno Farm your questions afterwards if you have some. So then we will connect you and guide it to Mr. Hegemann. So I think we can start with one question. Our filling machine is manufactured in 2008. Is there an option to upgrade such a machine with the new solution?
Yes, there are different options. So we have a whole department doing these rebuilds and upgrades, and all of the today's bespoken solutions are fully able to be upgraded. There are limits. There are still machines from us from 1950 or something in the market. So for them, it's a little bit more difficult. So we would need there the ETO approach. But yeah, we will have a solution for all of our customers.
Perfect. Thank you very much. That sounds very good. So next question is, we are going to plan a new production plant soon. Is Harvard able to do the engineering of a complete plant?
Yes, today I had the chance to present, according to the topic, some steps out of our world. But with our technologies I've shown in the beginning, we are also in the market and able and possible to deliver a complete plant. We have done logistical projects where we have automated a whole cement plant, or we have also done with some partners together a complete warehouse, for example. So yes, also there we would have solutions available.
Okay. So I check what is the main benefit of your AI solution?
Good question. It's always, I think, the question the normal, I would say, the normal people asking. It's a nice thing to have AI solutions, but what is my benefit? What could I do with that? For us, the machinery industry, in my feeling, is still in the beginning to see all the options and to see all the possibilities they could give to us. And what we always see is that we could have a higher degree of automation, have an easier work for the operators, because mainly these tasks which we today, or I today showed, are not liked by the normal operators. And if this we could for this we could use the AI solution, I think that's the most best approach to cover.
Thank you very much for your opinion. And then I would say, if you have any questions left, please feel free to use again the F&A button, and then I can forward it the questions to Mr. Hegemann. If not, please feel free to ask also your questions after the complete virtual talk to give it also to get also an answer from our speakers. So then I would say we have no questions left for now, and
Thanks.
I will thank you again. And last but not least, we have another interesting talk for you from Tobias Werner from Jakob Group with his topic about augmented reality, revolutionized pipework planning. I'm very excited. Have fun and enjoy the talk.
Yeah, hello everyone. Thank you for having me today. Can you see the right screen, or do I have to change it again?
You have to switch, please.
Nice.
Perfect.
Yeah, thank you. Thank you for having me today, and thank you to the two previous speakers with their really interesting approaches in the greenfield planning of production sites. And today I would like to use my time here to present you the way Jacob thinks that, or we think that augmented reality can revolutionize the pipework planning and mainly brownfield approaches. But first of all, let me tell you a bit about the company I'm working for. It's Jacob, the pipeworking company, and we are combining traditional craftsmanship in every our product since 1924. So last year we had the last of a 100-year party. So yeah, we are a family-owned company for 100 years, located in Porta, that's in the middle of Germany. We have around 650 people working for Jacob worldwide, and make roughly 140 million in revenue a year. And we are the market leaders in the modular pipework systems field. We have also like 6 data companies worldwide, 40 representatives, 4 production sites, mainly in Europe and the US, and in stock for fast delivery. We have over 1.3 million parts, which are mainly available in next day delivery. And for example, what it means to produce pipes, we made like 580 kilometers of pipework pipes in the year 2024. We're really looking for a state-of-the-art production technology, not only in our serial production, but also in the individual special part production. And we ship like roughly 130,000 packages this year. So it's a really high volume type of production field, a product field we're in. And what I can say is that billions of people come in contact with products that went through our pipes every day. And I bet that one of you or all of you have done today when you start the day with brushing your teeth or taking medicine. I hope no one does it, or needs to, but also breakfast or your daily coffee, tires, everything, air suction in your company or in your production sites. So around the clock, you come in touch with product that went through our pipings. So these fields are mainly, well, you see a stock image of our pipings, but the fields we are working in is mainly bulk material handling. For example, that mentioned like coffee beans, dust and air ducting, low pressure transportation, which is pretty interesting because like a bag of chips will be transported through the pipe system in low pressure. And also we have a lot of custom applications for like standalone air filtration, for example. Yeah, exactly. That's shortly to our company, that what we do, what we are good in, and what we're heading to is set by one of our company principle, which is we leverage digital technologies to make the life of our customer easier. And before we talk about what we make easier with what I want to present you today, we have to take a look on what is not so easy today or what takes long today. And that's the process of planning pipeworks in a brownfield approach. For example, for an existing production hall, you want to move a machinery, you need to replan the pipe system, you want to add a new machine, and you have to do it all while the rest of the production is still running, and you have to consider everything that is already there. So this is the field we are looking into today. And to tell you what that means, if you don't know it, then we take a look on the current process. It roughly takes 9 days to do a smaller to mid-sized pipe planning in the brownfield approach. And these numbers are like positive numbers. So sometimes it takes way longer. And the steps you have today to do is you still have to go on site. You have to take a look where you are. You have to do some measurements, especially if there are no drawings available. So you can use a 3D laser scanner, or you do it analog with a laser pointer or a meter stick or something. Then you have to digitalize the measurement. For example, taking this 3D laser scan, transfer it to a CD system, which can take up to 2 days, maybe even longer, depends on how big the data is. And then after all that, you can start doing the actual planning. You need a CAD software for that. You need the CAD data from our pipes, for example, our pipes for that, and then you do the planning on your computer in your office, step by step, like a Lego system. If you've done the planning, you will contact, or you have to contact your customer. Hey, is the plan we have done, is it okay? Can you confirm it? Can you approve it? And then there are some data or some tensions. Are the requirements of the customers understood? Does he understand the drawing? Because for me, myself speaking, is I sometimes have difficulties to understand 2D drawings in the 3D environment, for example. How does it fit there? Does it fit there? How is the real way of the pipework, etc. And if the customer approves, then you have to still make a part list out of your plan. So you have to somehow count the pipes you need, count the pull rings in our system you need, and we have a lot of customers that still do that by hand. So they sit there in front of the screen and really count every pipe and write it down. And if you have done that, you know what you need, and then you can place the order for at us. And that's when we say the planning is done, because then you're in a production or in the order. So as mentioned, there are a few challenges in the brownfield planning, not only the long process, but that's one main challenge. And you often have different hands that are doing the planning. For example, there are people going out to the measurements, creating the CAD data, then you have people doing the planning, you have the guys buying the stuff, etc., etc. And also a big challenge is that especially in an older industrial company, a country like Germany, often you have no current drawings of your production sites. We see that here, Jacob. We don't have. We try to keep them on track, but it's sometimes really hard to change every drawing every time something bigger changes. So it's not often that you really have accurate and on point drawings, and sometimes you even still have just paper drawings at your customers. You really have to consider every local circumstances. For example, emergency exits, other piping, machinery. Everything that is there, that is really there, that needs to be considered with what maybe can't be moved for your piping. So you have to consider it in your system. And also, as seen before, it's really time intensive. Sometimes you don't even have, it's not enough to measure one time. You have to go back, measure again, or you do the first planning. Then the customer says, it's not what we asked for. Then you have to go back, plan again. And what we got as a feedback from customers from us is that, we do the planning, we do it really accurate. For example, with a 3D scanner, we can do it in a millimeter way. We are really accurate to take the environment and digitalize it. But at the end, we are still not sure how accurate we really are. So we order up to 15% more material, so that at the day of the assembly, we can make sure that really everything is there, and we can fulfill the order. And also, there's sometimes no transparency, or the information is lost between the planning and the assembly. For example, there's no assembly manual, which leads to the say at the end, the assembler do what they want anyway. So all the exact planning at the beginning is somewhat over engineering, let's say, at the end, because on site, it's always different what really comes out. So this is the status quo of the brownfield planning, with what we see today in our daily business. And as our principal, we from Jacob said, let's do it different from here. Let's try a different approach. And for that, we built a software on a device, and we called it the Pipe Planner. And with that, we can do on-site planning. We need no extra measurements. We are 100% digital. We have a maximum precision, which is needed for the process. Roughly in the first field approaches, we cut the process time in half at least. We have a really high amount of automation. And what we also see is that the planning, approval, and ordering is in one process. So one person could do that. So we don't have these cuts these loss of knowledge in between different departments. And how we do it with our, as mentioned, with the software we call Pipe Planner, which is a augmented reality software. And for that, to use it, you only need this device. I hope you can somewhat see it. And I guess most of you know it. It's a Microsoft HoloLens 2. It's a AR glasses. Yeah. And we don't need internet access. We don't need really additional knowledge regarding the technology. It's really easy to use and to learn. Yeah, and it enables us to do the planning where we are and what we in the direct environment where the pipeline is later on needed. So let's take a glimpse at the new process. So we do it we could do it in smaller pipework in just a few hours. For example, you take the HoloLens or any other AR device, go to the place of request, so on site to your customer, you put on the HoloLens and start the planning where the pipework is needled. So you don't need any measurements, you don't need any 3D laser scanner. You can start planning directly with the parts from Jacobs, exactly the same parts as you do in CAD. And what is really interesting is you can hand over the HoloLens or show it on the screen on your computer, show the customer where you planned it. Hey, dear customer, please take a look. Is that the pipe system you had in mind? And he can take on the glasses and walk through the room, walk at 360 degrees around the pipe system, and can really see, okay, this is what we could build, and I approve that. Please feel free to order it. You can order, not know yet, it's still a prototype, but you can order then the pipe systems out of the application at the moment. You can, or what you also can do is export the order if you need to adjust it or need it as a PDF, for example. You can, what you planned, you can export it as a 3D plan, which is CAD capable. So you still have the opportunity to do the planning, go back into the office, adjust the planning, yeah, see if everything is really in place, and to also put it into existing drawings of the building, for example, so a documentation. And also what we can use is the 3mm4 as a construction manual. So the worker who is manual or a constructor, the pipe system at the end is really like, okay, this is part number 1, this is part number 2, this is a definition of 1 and 2. Yeah. On the next slide, I will show you a small video. Please excuse that this recorded in the basement of our main programmer. Don't worry, don't keep him there. It just was a nice environment to show shortly how in small areas with existing pipe systems you can start or you can do planning with our software. So really, this will start. So here you see he's wearing the glasses. You open the menu, then you have a starting point, which is a small blue point he's moving around. And what we programmed it for, it's attached, or it is attaching to flat surfaces. For example, the ground, the ceiling, walls, the end of pipes, the end of machines. And here we see a pipe that is ending in the middle of the room, which we now want to keep on planning. And for that, we developed a tool to adjust the starting point wherever we need it. So in the middle of the room, now you can choose the diameter you want, and now you just place pipe by pipe, like a Lego system, just by clicking your fingers through the pipe system. You can choose between every standard pipe Jacob have in the portfolio, rotate it, and as soon as you see the light blue data there, you can click it. You also can use bends, and you can rotate them, of course, because that's important. It's really easy. Just do it with the steering wheel. So you just approach, or you just place it where you want it, and continue from there. Exactly. And this is how you do all the planning. And as you can see, you can get as complex as you want. You have like the live part list there, which you can check. And what is the main feature is that you can export it right now, or you can export it, save it locally on the device, and later on use the file not only use the file in the CAD program, but also get the part list in a PDF format. Now you see the inventor for what we developed in a plugin. You choose the file you just saved, load it in, and it will automatically load everything in the right order as you planned it before with the AI device. And what is also really nice is that you now can manipulate everything. You can put it apart, you can add parts, you can change parts, just as you would do it normally with the in the, let's say, traditional planning way. What are the advantages of the Pipe Planner? We have a really fast planning. If you're a bit used to the software, maybe you see the dimension of the room where I'm in. You can easily plan a pipe system in like 10 minutes. It's really, then let's say like 200 meters in like half an hour or something, even if it's complex. You see what you get. Not only you see what you get, but also your customer can see what he gets. You can get the approval, you can see the collision. We also can turn on the collision control, which turns pipes that detect the collision red. So you see, okay, they have to twist it a bit or they have to change it. So all in one software, you have the planning, you have the collision check, you have the part list, you have the CAD documentation, and you can order all in one application. You have the full control, as I mentioned. The collision check is there. You can see if everything around is considered. You also can do, I don't know, maybe if you place a new machine, do the piping, hand it to the operator or the later on operator and see, hey, is it okay for you if the pipe works? Does go this way? Is it fine for you? Do you reach the valve in a approached way? You have everything at a glance. As I said, like the part list assembly instruction, which is really helpful if you have subcontractors. Yeah, and as I said, you really don't need a CAD system anymore, but we are still able to have a CAD capable or usable format. Yes, and that's all I said. Really, all you need is one glass or one device and a little bit of interest in new technology, and then it's really easy to use. And one of our customers who is trying it out at the moment, he really looks at us and says, with that device, with that software, planning starts to make fun, and that's really good thing. And in the Glatt presentation at the beginning, we saw the technical level. I had one of the parts in a greenfield approach, and yeah, we have some customers that have the technical levels that really looked a bit different, which are way crowded with a lot of pipes going through another, and that's really hard to do a really good measurement. And with the HoloLens, you can just put them on and start planning directly in these crowded fields, in these crowded environments, and really see, okay, my pipeline or the plan I have that fits in here, and I'm sure I have everything I need. The way I planned it works, and I can order it without any extra material. So yeah, that's from my side. Thank you all very much for your attention. And what I can say is, if you want to experience it live and try it out, visit us at PowTech this year, or feel free, of course, to contact me at any time. Thanks a lot.
Perfect. Thank you very much, Tobias, Werner. So interesting insights about what is possible with augmented reality. Thank you very much for this interesting talk. So now, as always, please feel free to ask now your questions over the F&A button at the bottom of your screen, or Q&A button at the bottom of your screen. So then I will forward the question to Tobias. So I will give you some moments that you can type in. And we can start with the first question. What do you need exactly on site to be able to use the app?
Yeah, as mentioned before, you just need the HoloLens, or later on a different device. At the moment, it's just available for the HoloLens. So you just need the HoloLens and the software. No internet, no additional computer, nothing. And you have it, if you wear it, I can demonstrate it like this. It looks a bit spacey, but you have your hands free. so you can still maneuver, and it's a see-through glass, so you see everything around you. If I don't know, a colleague approaches you or something, you can see him. If you walk into a crowded space, you can see everything, and you still can plan with the holograms.
Okay, perfect. So not very much that you need for that. So next question is, can I already use the app now?
Yes, you can, but we don't have like you can't download it from the App Store or something if you want to test it. So it's still a prototype phase, and we're reaching out to customers to get feedback. And yeah, you can test it. We can send you even the HoloLens to the hardware device where you can test it in one of your projects, or we come to your project or come to your company and test it again together. There are many ways how we can test it, or you can test it. Yeah.
Okay, perfect. So if someone will test it, they should contact you or Jakob directly.
Yeah.
Perfect. So now we have a little bit of time. So if you have any questions left, please feel free to ask the questions. If you have questions afterwards, please feel also free to contact Tobias, Werner directly, or as I said, over our exhibition team at PowerTech-Technofarm at nürnbergmesse.de. So then I would say we have no questions left. So then thank you, Tobias, Werner, and also every other speakers today, Heiko, Hegemann, Dirk, Steinhäuser, for your interesting talks. And now I can close our webinar. So thank you for joining us to the virtual talk today, and the upcoming dates of the next virtual talk series can be found on our website at powertech-technofarm.com or on our social media platform LinkedIn. So please stay tuned and feel free to join us again. And we're also very much looking forward to welcome you to PowerTech Technofarm, Fachpark and Partech this year from 23 to 25 September 2025. So have a nice day and see you soon.